Okay, anybody got it?
I
is what you got to put in here so that when you square omega and multiply all these things together, you get this, right?
I got
So, the easiest way to get it
9,000.
is write this down, solve for I, and plug in what you know, right? You know the kinetic energy, you know omega. So I equals twice the kinetic energy over omega squared, right? Which is 405,000 gram centimeter squared per second squared divided by the square of 3 radians per second.
Don't forget the 2.
Okay?
What about the half?
I forgot the 2, right?
Yeah.
What, is that all I forgot?
Yeah.
Because, yeah, I was just figuring it out in my head and it wasn't going to come out right. Okay? Because I know it's easy to figure out what it should be. Okay. So that is what? That's going to be 810,000 divided by 3, right? Or by 9. Okay? Which is going to be 90,000?
90,000 grams centimeter squared over radius.
Yeah, and then we got to be careful. It's gram centimeter squared times second squared over radian squared, right?
We're going to the second squared underneath grams centimeter squared.
I don't know, it's in the denominator here, and when you,
Right up there at the top.
oh yeah, I forgot, yeah. Yeah. I mean, I know what the, you know, I is just mr squared. But we'll do that with symbols, okay? So this is, maybe we won't even work that out since we had to spend so much time talking about what a radian was again. Okay? So you have centimeter squared over radian squared. What's centimeter squared over radian squared? What's a centimeter divided by a radian? Well, a centimeter of arc divided by a radian is a centimeter of radius. Okay? Or a centimeter of radius multiplied by a radian becomes a centimeter of arc, right? So when you multiply or divide a centimeter by a radian, in most cases, the radian is just going to go away. I hope you understand what I said. If not, go back to this video. Okay? I'll probably say it again because it comes up. But you have 90,000 gram centimeter squared. Okay? Now, mr squared is 100 grams times 30 centimeters quantity squared, right? Which equals what? This. Okay? Now we can do this in symbols, and we would prove very easily that for if all your mass is at some distance r, the moment of inertia is mr squared. Okay? So, and all we have to do is write this down in symbols. V is omega r, right? So let me just kind of write that down here in the middle. It takes about 2 lines. V equals omega r, again, not because it's a formula you memorize, you'll confuse it. Okay? But because we understand what a radian is. Okay? So kinetic energy is 1/2 m times the quantity omega r squared, which is 1/2 m r squared omega squared. Equals 1/2 I omega squared where I is r omega or omega r, whichever way you want to write it. Okay? Now, again, this is a derivation you should be able to do just as quickly as the other derivations that I've asked, and that's going to be on the test. I mean, it's going to be among the problems, among the derivations I ask you to do, right? And y'all didn't do great on derivations. Most people, when they ran into a derivation, did something right, which is a start, okay? But then typically mess something up, although not always. Some people got the derivations. Derivation of the formula for kinetic energy. You got to know these things. Okay, so anyhow, this is it, right? Okay, now let's look at a much more complicated situation where we've got 25 gram masses at 30 centimeters and 25 gram masses at 15 centimeters. Pair of 25 gram masses here, pair of 25 gram masses here. So you still have a total of 100 grams, right? You got 2 25s, 2 25s, and 4 25s. It's like 4 quarters, that's like $1 worth of rotational kinetic energy or something like that. Okay? Now, so we have exactly the same mass, but it's distributed differently. Okay? Some of it is closer to the axis of rotation. Now, is that going to make this thing easier or harder to get moving, to get into rotation?
It should make it easier.
Because why?
It'll have less kinetic energy.
It takes less kinetic energy to speed it up because these masses will have less kinetic energy at whatever angular velocity, right? Make sense? Okay. So go ahead and figure that out. I'll write out the details, but 2 25s at the ends at 30 centimeters and the other 2 halfway to the center, right? At 15 centimeters. Still 3 radians per second.